Namaste guys and welcome to the new session of C programming. So in our yesterday's video we have seen history and application of C programming. So in this video we are going to cover some theory part which is number representation and how we can use different type of number representation in our C programming. So let's start them one by one. So there are four types of number representation which we can use in our C programming. The first one is decimal number. As we all know, decimal number have base of 10 and our second number representation is octal. So our octal numbers they have base of 8 and our third number representation is hexadecimal which has base of 16 and our last number representation is binary numbers which has base of 2. So these are four types of number representation which we can use in our programming. The decimal numbers meaning that we can use 0 to 9 digits to count our numbers, and in octal numbers we can use 0 to 7 to count our octal numbers, and we can use 0 to 9 and A to F to count our hexadecimal numbers, and for our binary numbers we can use only two digits which is 0 and 1. So these are four type of number representation which we are going to master in our this class. So let's see them one by one and how we can convert from one number representation to another number representation. So before that, let's just understand how to write these numbers. So in decimal number, these are our normal numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 and so on. So for decimal numbers, these are of base 10. So for octal number, we are going to use our base 8. So to count these numbers 0, 1, 2, 3, 4, 5, 6, 7 and again 10, 11, 12, so on until 17 and again 20. So this is how we can count our octal numbers. So after 7 we are going to represent the next number with 1 and 0. So our hexadecimal numbers they have base of 16. So to count these numbers, first we are going to use one prefix called 0x. Then we are going to enter our number. Let's count from 0, 0, 0x0, 0x1, 0x2 until 0x9, and again the next number will be 0xa. To represent our 10th number we are going to use our a. So on 0xb until it reaches 0xf, which is our 15th number. So we are counting from 0, so until it reaches 15th we are going to count this number. So after 0xf, so after 15 our next digit will be 0x10, then again 1, so again until it reaches 1f. So our next number representation is binary which is of base 2. So we are considering this for 4-bit number, so we are going to use only 4 bits. So our 0 will be 000, 1 will be 0001, for to represent 2 10, 0011, 0100, 0101. So this is how until it reaches our 15th number which is 111, until all the big bits become 1. So this is our 15th position and this is our 0th position. So for 4-bit number we can count until it reaches 15th position where all bits are 1. So for 8-bit number this number will be huge because we are considering 8 bits until all the 8 bits become 111. So this is how we can count in different number systems. For decimal we are going to count as our normal numbers, and for octal we are going to count until it reaches 7 and again going to start with the 10, 11, 12. For hexadecimal, we are going to count until it reaches F. For binary, until the all bits become 1, we are going to count until that number reaches. So let's just understand now how we can convert from one number system to another number system. So let's start with the decimal to binary. So to convert or any number from decimal to binary, we are going to use one method. Let's say our example is 45. So 45, it is a decimal number. So we are going to convert this decimal number into our binary number. So what you're gonna do is, so first we are going to take our number 45 and we are going to divide it by 2. So let's just divide it. 45 divided by this 22 and our remainder is 1. 11 and our remainder is 0 and our remainder is 1. 2 2 the remainder will be 1 and 2 1 the 0, remainder is 0. So when we get all these our reminders, we are going to count from this section to this section. So let's write this number 1 0 1 1 0 1. So from here you have to write 1 0 1 1 0 1. So this is our binary number for our decimal number 45. So this is how we can convert our any decimal number into our binary number. So we have seen how to convert decimal number into binary numbers. Now we will see how we can convert binary numbers into our decimal numbers back. So let's take one example, 1101. So to convert this binary number into decimal number, first we are going to do to write our positions of each bit. So this is on this 0th position, 1, 2 and 3. So means we have 4 bits. So to do this calculation, what we cannot do is, let's take this 1th bit into 2 raised to 3rd positions, mean 2 raised to 3. So we are going to do this for all the bits. So this is 1 bit into 2 raised to 2 plus 0 into 2 raised to 1 plus 1 into 2 raised to 0. So as you all know, 2 raised to 3 is 8. So 1 into 8 is 8 plus 2 raised to 2 is 4. So 1 into 4 is 4 plus 0 into 2 is 0 and 2 raised to 0 means 1. So 1 into 1 is 1. So 8 plus 4, which is 12 and 1 13. So this is our 13 in decimal. So decimal number equivalent for this binary number is 13. So this is how we can use our binary numbers and then convert it into our decimal numbers. Let's see our next conversion. So we have seen how to convert our decimal numbers into binary numbers and our binary numbers into decimal numbers. Now let's just understand how we can convert our decimal numbers into our octal numbers. So for these octal numbers, let's take one example. Let's say 96. So to convert this 96 to our octal number, let's divide it by 8. So every time you divide it by 8, you are going to save its remainder. So 8 12s are 96, means remainder is 0, and 8 1s are 8, means remainder is 4. So we are going to follow the same approach. We are going to count this number 140. So 96 equivalent is 140 in octal. So this is how we can convert decimal number into octal numbers. So for octal to decimal, we are going to use the same approach as we used for binary to decimal. So let's take our octal number. Let's say I am taking 41. So let's write their positions 0 and 1. Now let's write equation for them. So 4 into 8 raised to 1 plus 1 into 8 raised to 0. So 4 into 8 raised to 1, 4 8s are 32 plus 8 raised to 0 means 1 and 1 into 1 is 1. So this is 33. So this is our decimal equivalent for our octal number 41. So this is how we can convert octal to decimal and decimal to octal. So let's understand our next conversion. So now to convert from decimal to hexadecimal or hexadecimal to decimal, so we are going to use same approach. let's take one example, 528. Take this 528, but now we are going to divide it by 16. So 528 16 means 33, and remainder is 0, and 16 2s are 32, and remainder is 1. So this is our hexadecimal number 0x210. So this is our hexadecimal number equivalent for decimal number 528. So now let's do our hexadecimal to decimal number. So let's take one example. Let's say 912. So to convert it, we are going to use our same approach. First, let's write this position 0, 1, 2. Now 9 into 16 raised to 2 plus 1 into 16 raised to 1 plus 2 into 16 raised to 0. So 9 into 16 raised to 2 is nothing but 2304 plus 16 into 16 raised to 1 is 16. 16 into 1 16 plus 2 into 1 is 2. 2304 plus 16 plus 2, which is nothing but our 2322. So this is how we can convert hexadecimal to decimal. So now what if we get a binary number, and let's say we want to convert it into octal number, or if we get a binary number and let's say we want to convert it into hexadecimal. So how we can do these operations? Let's try them out. So whenever you get a binary number, let's take one example, 001 010 010 010. So let's say this is our binary number and we want to convert it into our octal number. So now what we are going to do is we are going to create group of 3. So let's create our group of 3 here, here and here. So now we are going to count this number. So this is a binary number, and what is the decimal equivalent for this? It is a 2. This is also 2. This is also 2. This is a 1. So this will be our number. So 1 2 2 2. This is a octal representation for our binary number 001 and 010 010 010. So to perform binary to hexadecimal, what we are going to do? We are going to follow the same approach. Let's take one example. Let's say 0010 1001 0010. So as you can see, we have our binary number. So for to convert hexadecimal, what we are going to do is we are going to make group of 4s. So here we have made group of 3s. Now here we are going to make group of 4. So 0010 will be in one group, this number will be in another, and this one will be another. So we are going to get decimal equivalent for this. So this is nothing but 2, and this is nothing but 8 plus 1, which is 9, and this is nothing but 2. So the total equivalent number is 0x292. So please remember this point. Whenever you mention or whenever you write a hexadecimal number, use this 0x prefix, then mention your number. So this is how we can obtain our hexadecimal equivalent for our binary number 0010 1001 and 0010. So you can use any kind of number and use the same approach to get this number. So if you get into any problem where we have less number to put into group of 4s, means if you have only 2 digits remaining, then you can include 2 zeros. If you have one place remaining, you can use 1 0. So this is how you can fill up. Let me show you. What if we have number 10 1001 and 0010. So whenever you get this kind of number, means if you do group of 4, these two number will be remaining. So you need to add 2 zeros into this number. So at the end, you are going to get the same number. So this is how you can convert from binary to octal or binary to hexadecimal. So let's use our last method, which will be to convert from octal to hexadecimal and hexadecimal to octal. So whenever you are asked to convert a octal number into hexadecimal number, or hexadecimal number into octal number, we are going to use one simple approach. So let's take one example of our octal number. So let's assume 72. So to convert this 72, we are simply going to write this number. So since it is a octal number, so we need to create a group of 3 of binary number. So this will be 010 for in binary for group of 3, and the 7 will be 111. So this is a binary representation of this octal number. Now we are going to write this same number 010, and now to convert into our hexadecimal number, we are going to create a group of 4s, and let's add 2 zeros. Now this will be our 8 plus 2, which is 10, means A in hexadecimal, and this is our 3 number, which is 3. So this is our 3A, means 0x 3A is our hexadecimal equivalent for our octal number 72. So this is how we can obtain our conversion of octal number into hexadecimal number. So let's do for hexadecimal to octal. We are going to use our same approach. So let's write one hexadecimal number. Let's say 0x2b. So now to convert this to b, what we are going to do? First we are going to convert it to binary number, and then we are going to convert it into our octal number. So let's convert this into a binary number. So let's write 2 and b, and let's create a group of 4s. So b is nothing but our 11. So how we can write our 11? 1011. So this is our binary representation of 11, which is our hexadecimal b. So to write 20010, so take this binary number 00101011. So now we are going to create group of 3s to convert into octal number. So let's add 1 0. So 0, and this is nothing but 4 plus 1, which is 5, and this is 3. So our octal number is 053. This is octal representation of hexadecimal number 0x2b. So this is how we can convert different number systems into another number system, and we can represent this number at any form given. And this type of number conversion we are going to create programs in future. For now, let's just understand these numbers play a very crucial role while you are performing a programming task. You need to be familiar with these type of numbers so you can convert them easily and you can understand what's going on inside the program. So this is it for now. We are going to continue in our next session, and in our next section we are going to write few programs. So before that, make sure you like our video and subscribe to our channel to follow up this series, and make sure to comment your reviews. See you in the next section.